Today we're talking about auxiliary views, and auxiliary views are basically a multi-view that is not at one of the main angles, one of the principal angles, not the top, front, or side. So in these problems, typically you're asked to find the angled face, and then draw the angled face with the correct proportions. This is important because in a typical multi-view, you cannot actually trust the dimensions of an angled face, so sometimes you want to look at it directly at that angle. I'll explain this a little bit more in a moment. So, in this example, we're given the top view, so horizontal, we're given front, and we're given profile. In this question, we need to identify the inclined surface, draw a properly aligned auxiliary view. So, in terms of properly aligned, what that means is we're drawing it perpendicular to the face where we see the angled plane. The face that I'm interested in is this one. I'm going to be looking at it directly parallel to that angle. So my sight lines, like let's say this is my eye, right? I'm looking at it this way. So that means that I'm going to project it out from the angled face. So I will take some construction lines, and I can project out the exact width perpendicular to this angled face to make sure that the height of that face is correct. Can I take that height directly from the isometric? Not necessarily, because when something is at an angle, you can't trust that this dimension is correct, especially if it's not 45 degrees. The only dimensions in an isometric that you can trust is anything that is parallel to one of the principal axes, and that's in essence like this one, this one, this one, this one, etc. So we'll use that principle a lot. Okay, so as always, we start with the bounding box. And the width of our bounding box, since we already have the height, is going to be determined by what we can see on the profile view. So this face corresponds to this part of the profile view from here to here. So I can trammel that distance and transfer it over such that I have enough space here. So I'm going to start over here and end over here. I can complete my bounding box. Okay, this is a very simple question because there's really only one feature on this face that I'm interested in, this thing. If I were to draw what the outline of this looks like, just to make it really clear, the face that I'm drawing is this. Right? So I need this feature. How do I locate the position of that? Well, I can actually see it, luckily, on my front view. So if I project this over, again, perpendicular, I now know exactly what this distance is over here. Conveniently, now I can just continue to take these other dimensions. So I've trammeled this in advance. Oops. Trammel this here. I can grab this width on either side. And then bring them up. So I can just go with darker lines all the way around the outside of my shape. And that's basically how we do this one. But are we done? Not quite. We actually have to label and include the reference edges. So reference edges are basically how we got to here from a typical multi-view. So I'll draw one from the top view going down to the front view. So this is saying top view is over up here. If I fold it down, it's going to be the front view. So I would draw H on one part and F on the other. So now if I'm going from the front view to the auxiliary view, I need another reference line. So I'll draw a reference line over here, just right up on the edge of my shape. And I will say this is the front view, right? And this is the first auxiliary view, or just the number 1. So that's how we do that question. Let's move on to our actual solution. We can see this over here. Okay, so then there's the actual sketching assignment, and this is a little bit like, oh, wow, this one was super simple, and then you get to this and it's like, what? So let's do some of these together. I'll switch to paper. Okay, make sure you write your name and section on this one, but we're gonna go through these really slowly because this is a really tricky subject. So in our first question, just make sure you read all of the instructions. We have the front view, we have the profile view, we're missing the top view, and we also are missing the isometric. So not only is this like a missing view problem, this is also an auxiliary view problem, and that's why there's so many. It tells you the angled face that you're interested in, which is this one. So then I know that the general outline of this one is going to be shaped a little bit like this, but it's not going to have those exact dimensions. Let's try to draw this out. First, I'm going to trammel the width to get my bounding box. It's the same in both directions. The total height, I can trust this height. It's close, but not quite. And make sure you complete the entire bounding box. In this case, I'm making adjustments because I know that the front edge and the back edge should be aligned with each other. This is because those dimensions that I first got were the same. Okay, I have a rough bounding box, and we can start to transfer some of these things over. So, just like a typical multi-view problem, I see changes of plane. I see 1, 2, 3, and then 1, 2. So on the profile view, this one and this one are probably located right up against the edge of the bounding box, and you'll see how this comes together in a moment. Let's go visible, go bold on some of these lines that we know. Here. And we can get the overall height. Here. Okay, now we have a little bit of a trickier job on our hands because we don't really know where to go from here, right? I know that there are changes of plane, but where exactly? So that's where we're going to have to do a little bit of work. Okay, so I see that these are on the same plane, so this face corresponds to this thing over here. How do I keep going? Well, let's try it a little bit. So the back edge is going to be square, right? I don't see any other angled faces over here. So that means everything along this is going to be parallel, right? So coming up to that feature at the top, I need to represent this. So this height over here will tell me how far this thing is coming up in multiple different planes. I'll just do this. So using what I saw in this one and this one, I defined a square on the very top of my object. Alright, everything along this face, this diagonal face, is going to be coplanar. So let's try to figure out how we're going to locate this. First of all, I know that this thing has to come down straight for some amount of time, for some distance, and I can actually use the distance that I see here. So this is coming vertically downward, and then it's coming out, and that shows this change of plane over here. Okay, what else can I show? I know that everything is going to be coming basically along the same plane, so I'm going to bring a construction line down this way, just to show what's going on over here. And this is going to be at the angle of the inclined face that I'm trying to draw with my auxiliary view. First of all, I see this face, so I can draw it parallel to the original line that I drew. Then, this end point over here defines this feature. Do you see it starting to take shape? Good. So parallel to these, there's also another line coming up. But this one is not coming up all the way to the corner. In fact, it doesn't make it that far. It's only going to come up at a certain distance. But how do we know what that distance is? If this were actually represented, so I see on the front view, this height at an angle looks something like this. How can I figure it out? Well, that requires a little bit of, geometric leaps of thought. But perhaps, what if I took this distance and I projected it straight downward from here? So if I took this and projected it straight downward from that corner, if I then brought it to the face parallel, that actually gives me the same distance. So that's a principle of geometry, right? This is like the back face, and what I'm trying to draw is the hypotenuse of that right triangle. So I brought that distance downward, and then brought it out over here, and that actually gives me the height that I need to bring this thing to. And that's why this can be a little bit tricky, but once you get started, and practice this a lot, of course, it will become a lot more straightforward. So that's how I draw the isometric view of this particular object, and you can kind of see how front view, profile view, they work out. That's the correct way to do this one. And this hidden line over here is represented by this thing over here. So what does this look like from the top? Well, first we need to get our bounding box. So again, we'll use our height and our width. And we can just draw all of the features. How do I locate how far over to come for this one? I can actually just take this distance over here too, in the profile view. So that's all the old stuff. Now we actually have to get into drawing the auxiliary view. So I know I'm going to want to draw it on this one. That's where the asterisk is marked. I'll follow the same steps that I did in the example. So now I have the height, I have the width. I'm going to do some dimensioning. How do I know how far this thing is? Can I trust either of these dimensions? No, right? But I do see in a hidden line where that feature is over here. So I can project it over. Now, figuring out how far this comes in is actually going to be the same as what I can dimension off of one of the multi-views, because that's something that's parallel to one of the principal axes. So I can take that dimension and bring it over. So this one over here. What else is happening here? Well, I've got to get that top part. How far does it come down? I can just project that feature over. And I just mark all of my reference lines. Front profile, profile to first auxiliary view. So you see how this shape is basically the same as this one, but it's a little bit stretched out per the true dimensions. And the face that we drew was this one. That's you do the first question. I'm going to run through the other two and not really talk much, but you can just follow along. Try these first because this is an important skill, and then check your answers here afterwards. So you can pause the video now and then give these other ones a shot. If you get stuck, feel free to fast forward to the point where you think that you might be. and that's all.